Today on my channel, Roadzone Reviews, we're diving into something big. Tesla's rapid rise in Austin points to more than just growth. It signals a silent transformation. By the end of 2023, the workforce at Gigafactory Texas nearly doubled, reaching around 23,000 employees. And while Elon Musk hasn't officially confirmed it, the buzz around Tesla's next major release is building. All eyes are on the much-anticipated Model 2, priced as low as $9,875. This EV is rumored to feature a cutting-edge Axial-Flux Motor, a revolutionary compact system that blends performance with cost-effectiveness. Powered by Texas's expanding production force, the Model 2 could usher in Tesla's next era of true mass-market EVs. If you're keen on staying ahead of these game-changing updates, be sure to subscribe to Roadzone Reviews. We're on the road to 139,587 subscribers, and don't forget to smash that bell so you never miss a major Tesla announcement. Let's start with something most people overlook. The real heart of any EV is its motor. And Tesla's potential. The use of a new Axial-Flux motor in the Model 2 could be the breakthrough we've been waiting for. Unlike traditional radial motors that use a cylindrical magnetic flow, Axial-Flux motors guide magnetic force across a flat disc-like plane. This major structural shift results in motors that are far thinner and more space-efficient, which is why they're often nicknamed pancake motors. These motors typically feature two flat stators with copper windings that sandwich a rotor embedded with permanent magnets. This layout increases torque-generating surface area while drastically reducing thickness. To put it into perspective, where a radial motor might measure up to 300 millimeters thick, Axial-Flux motors can be as slim as 50 to 100 millimeters and still deliver equal or even greater power. So what does this mean in the real world? With Axial-Flux motors, Tesla isn't just saving space, it's reinventing how performance, efficiency, and design come together. These motors can provide 30 to 50% more power for their size and weight compared to traditional designs. A unit weighing just 20 kilograms can produce up to 250 kilowatts. It's a kind of output that makes the Model 2 both affordable and exhilarating to drive, since they're flatter and lighter. These motors can be mounted closer to the wheels or in otherwise unused areas, giving engineers new freedom to optimize weight distribution and vehicle balance. Their flat shape even spreads heat more evenly, which helps reduce the chances of overheating on long drives or high-speed trips. In some real-world tests, Axial-Flux motors have demonstrated up to 30% better heat dissipation than their radial counterparts, an important boost to performance. Reliability. Manufacturing-wise, Axial-Flux motors come with serious cost and production advantages. Their minimalist design means fewer moving parts, no long shafts or bulky support structures, which makes them faster and cheaper to produce. Industry analysts suggest Tesla could cut motor production costs by 10 to 15% per unit when mass production ramps up. That cost savings is critical if Tesla aims to deliver the Model 2 at its rumored $9,875 price point. Now here's a question for you. Do you think a thinner, lighter, more efficient motor could be the key to making EVs both high-performing and affordable? If so, drop a comment saying Axial-Flux and let us know if you believe this motor will help Model to dominate the EV market. Let's dig deeper. What kind of performance jump can we expect from a motor like this in real-world driving? First, there's range. Axial-Flux motors boast energy conversion efficiencies of 96 to 98% compared to 92 to 94% in older radial motors. While that may seem like a small percentage, over a 300-mile charge, it could mean an extra 15 to 20 miles of driving, all without increasing battery size. Then there's acceleration. Thanks to their compact layout and shorter magnetic paths, Axial-Flux motors respond faster and deliver torque more directly. The result? Sharper takeoffs, quicker 0 to 60 times, and more responsiveness in daily driving, whether you're navigating traffic or overtaking on the freeway. Reduced energy loss also plays a part. Since these motors generate less heat, more of the battery's energy is used to propel the car instead of being lost as waste. That means less reliance on the cooling system and longer-lasting performance. Regenerative braking, another crucial EV feature, also gets a boost. With Axial-Flux motors, Tesla can harness kinetic energy more efficiently when slowing down. This enhanced regenerative ability means more power flows back into the battery, slightly extending range and reducing brake wear. Some estimates say that regen braking paired with Axial-Flux technology can improve energy recovery by up to 15% versus traditional systems. So here's your next question. Do you believe Axial-Flux motors can truly help the Model to drive farther, accelerate faster, and conserve more energy? If so, make some noise in the comments. Now imagine this. What if the motor didn't just impact performance but also reshaped the entire vehicle's look and driving feel? With a pancake-like Axial-Flux motor measuring only 50 to 100 millimeters thick, Tesla can design the Model 2 with a much lower ride height, Lowering the car by even 20 to 30 millimeters reduces aerodynamic drag, improving range by an extra 5 to 7%, while giving the car a sleeker, more modern look. Engineers also gain more flexibility in where they place the wheels and suspension systems. By pushing wheels closer to the corners and freeing up underbody space, Tesla can make the Model 2 more agile and stable while also increasing cabin volume. That's a win-win for handling and comfort, especially in tight city driving. On the exterior, less motor bulk allows for a cleaner, more aerodynamic design without awkward bulges or unnecessary panel breaks. Internally, weight distribution improves to axial-flux motors weigh 10 to 20% less than conventional ones and can be placed lower and more centrally within the car. That enhances cornering ability, braking balance, and general responsiveness, making the car feel more intuitive and planted at all speeds, especially in urban environments. These subtle changes can be the difference between a frustrating drive and a smooth one. If you're someone who's tired of feeling cramped or off balance in your daily city commute, comment Model 2 wins, because this might be the EV you've been waiting for. Let's talk interior. One of the most overlooked transformations thanks to axial-flux motors is how much more usable space you get. A typical radial motor can take up 70 to 90 liters beneath the floor. In contrast, an axial-flux motor may use only 50 to 65 liters, a 30% space reduction that opens up more legroom, deeper trunks, and clever storage areas that wouldn't otherwise be possible in a car this size. One key improvement is a perfectly flat floor from front to back. A rare feature even among modern EVs, that extra 30 to 50 millimeters of foot space can drastically improve passenger comfort, especially for those sitting in the back. The compact motor layout also allows for more flexible seating arrangements. Think fold flat front seats, adjustable rear seats, and hidden storage compartments under the floor. For a small car like the Model 2, where space efficiency is everything, these features could make it feel like a segment above in comfort and versatility. Even getting in and out of the car becomes easier with less underbody bulk. Tesla can lower the step in height by 20 to 30 millimeters without sacrificing road clearance. That reduction can make a noticeable difference for seniors, kids, or anyone juggling groceries or luggage. Research shows that a 20 millimeters lower step in height can cut the effort needed to enter the car by 5 to 8%. So next time you're climbing into a compact car, imagine how much smoother it would be with that subtle design change. Now let's get real about cost, reliability, and the future. The Model 2 isn't just about being smaller or faster, it's about being more affordable and future-proof. The streamlined structure of axial-flux motors means fewer components, simpler manufacturing, and easier assembly. By eliminating complex shafts, multiple bearings, and extra support brackets, Tesla can reduce motor costs by up to 15% once production scales. That's a big step toward achieving that sub $10,000 price goal. And since these motors generate less heat and contain fewer parts, they're also more reliable, which keeps maintenance costs lower over time. For a high-volume car like the Model 2, that's a huge benefit. Scalability is another key factor. Axial-flux motors are easier to manufacture in large numbers and require less specialized equipment. That fits perfectly with Tesla's Gigafactory Texas plans, where mass production is expected to accelerate in coming years. What's more, the adaptability of these motors makes them suitable for everything from compact cars to light commercial vehicles. By standardizing this efficient motor design across its lineup, Tesla is preparing not just for the Model 2, but for an entire ecosystem of future EVs. Finally, there's the environmental upside. These motors convert more battery energy into motion, waste less as heat, and use fewer raw materials, shrinking Tesla's manufacturing footprint per vehicle. All signs suggest Tesla's silent investments in this game-changing motor technology, combined with Gigafactory expansion and long-term strategy, are converging toward a pivotal moment. The expected launch of the Model 2, packed with axial-flux innovation, could mark 2026 as the beginning of true global EV adoption. But this isn't just about one car. It's the quiet launchpad for a new era of affordable, efficient, sustainable electric mobility. And it all starts with a motor that doesn't just drive a car, it drives a revolution.